Building a solution is part of a job. Being able to recover the solution is another part of the job. But making sure that the job is doing what you expect it to is a critical part of an operation and needs monitoring. My name is Bob Tickelman. I'm excited to introduce and bring you through Azure Monitoring and what it can do for you. Let's get into this. Building a solution is going to be great, but if you don't have a way to make sure that you're delivering on the business needs and requirements in the expected manners and times, how do you know that you've done the job correctly? Azure Monitor is going to provide the tools for us to be able to measure the outcomes expected, as well as provide tuning to make sure that performance is optimized to meet the requirements of the business. We're going to take a look at the key capabilities and the tools and data available to us so that we can make these judgments and value proposition proposals to the business. When you take a look at working at the business, having numbers is one thing. I often say that 85 degrees is a great temperature if you're on a beach and you're willing to go have another beverage. You're about to die if you're in a cold climate and you have hypothermic. So the numbers by themselves really don't give you what you're looking for. You have to have usually a group of other information to use to bring to bear on that monitoring value, as well as having a bench line to compare it against. You're going to be able to use these tools to identify what the business outcomes are, determine the key metrics that are going to be used to determine are they being met, use those metrics to be able to set the baseline, and then monitor against that baseline to make sure that they're being met or make any adaptations or modifications to either achieve or exceed the business outcomes. So these capabilities are going to grab a set of tools. We're going to have tools to visualize, plan, and predict the entire life cycle of monitoring. When you take a look at Azure Monitor, and I've used this term for other services inside of Azure, it's the one ring that rules them all. We've been able to collect information over a long period of time because a lot of this information has been available in other formats. I used to be a premier field engineer for the System Center Configuration Manager product, and I could tell you more about your device that you were sitting at remotely. I could tell you more about it than you could by sitting at that physical device. The ability to collect this telemetry information has been vast and been around for a long period of time, and so Azure is nothing new. Microsoft is constantly monitoring the absolute infrastructure of everything inside of Azure. We showed you in a previous recording that Microsoft is monitoring. We know what services that you have running, and if they're not working properly because of a failure on our part, we have the capability to respond to that in near real time and spin those services back up. Now, self-serving, we also have to know what's going on so that we can bill it. And so we have a billing construct that against your subscriptions that you have and your tagging that you're working with, we can tell you down to the minutia piece what services were used, for how long, where they were used, and how much it's going to cost. And so when you look at that landscape, Azure Monitor is not only a service that's used by us as the hoster, it's been given to you as the user of these services to also get the telemetry that you need to make the business decisions that you have to make. So when you look at this landscape, as I said, it's nothing new. These services and devices have been emitting this information, and it's based on an industry standard called a MIB, or Management Information Base. Hard drives are spitting off how much space they have. Hard drives are spitting out what temperatures they're running at. What's the head speeds that they're reading? What's the IOPS that they're working with? Network cards. All of these devices have been built and designed to emit specific metrics and log information that device is responsible for. Azure Monitor is the tool to collect all that information into a single location. And it does it not only for Azure, but you can use this to collect the telemetry information from on-premises, as well as your other cloud provider services. So that single pane of glass to get all this information in a single location. Now, looking at the landscape that we have here, I want to go through this chart that's on the left. And I want to start at the bottom and start moving up. So there are some customer sources. As I said, we can use the Azure Monitoring Agent to extend the monitoring solution to any location that you control. So if you've got some on-premises devices, you can then take those sources and feed them into Azure Monitor so that they can be included in your single pane of glass. Now looking at the gray area and above, we talked about a series of scopes inside of Azure. There's the Azure tenant, which is your entry point into Azure. There's a whole bunch of information that happens at the tenant level. Now, if you have two tenants, you're going to have to find some way to aggregate that information and pull it together into a single location if you wanted that kind of visibility to it. Now, this is where things like Azure Lighthouse, as well as Log Analytics workbooks to be able to bring this information together might do that for you. But the monitoring is reported back at the tenant level by default. We then take a look at management groups. They're not in here, but what we have is subscriptions. That's the billing construct. Anything that triggers a billing component gets measured against the subscription that we can pull that information from. For example, Azure Storage, you only pay for the storage that you use in the monthly time period. So as it fluctuates up and down, you're only charged for that amount of storage for that amount of time, whatever the smallest billing increment is. Now, in addition to storage, if it's just sitting there idle, the only charge you're going to have is storage costs. But if you're accessing the information, there's read costs, write costs, there's a number of different costs that go along with this, and they will all be broken down for you. And this is one of the reasons why in the tagging session we say you may want to tag, because as your subscription comes out, it's just going to lump that detail into a roll-up of numbers that you can now drill down. And if you've tagged things properly, you should be able to filter this data so that you can say looking for tag cost center 1001, and all those resources to that cost center would then come out of that mass of information to get the discrete values that you're looking for. Both of these are available to you as well as Microsoft. So the tenant level information is available to both of us. The Azure subscription information available to both of us. The actual Azure resources and their uses, we saw that there's log information and metric information at the actual resources that you can then bubble up and see in the graphical interface or pull off into a reporting system. When we start looking at the operating system of the workloads that you're dealing with, so we've talked in other modules about virtual machines. We know that a virtual machine is running, so if you have a VM, we know that the VM emits 95% CPU. That's what Microsoft sees, but we have no idea what is causing that workload, because inside of Task Manager, the discrete values of that information exist inside of the virtual machine. Microsoft has no visibility to that information. It's up to you to take that information and emit it so that it appears into your metric and log information for your Azure Monitor. Same thing with the containers. We get some general use. Oh, that container was launched at this moment in time. It's taking this much memory. It's taking this much CPU. This is the network traffic. We have no visibility of the activities that are being performed. That information from within inside of those services is available to you, and you have to configure your services to emit that information into Azure Monitor. Now, if you go back to some of the sessions that we've recorded previously, you'll see that I even identified there's a piece that you could actually enable to now emit that automatically for you, or do you have to go in after the fact and set that up? But those are going to be workloads that you're dealing with. Dealing with the IaaS, or the infrastructure as a service workloads, once again, we get some general numbers available to you, but not us. And then you get into the customer apps and the custom apps that you're working with. Those are only going to be made available if you have a thing called an Application Insights. An Application Insights account is an Azure capability that you enable that creates a storage location that gives you a key that you can then include in your application code to emit things like how many unique web pages visits did you have? What regions did they come from? What IP addresses were used? How many times was this button clicked on? What is the average load time for your pages that you're dealing with? All of that information or custom app information is available, but it's up to you to configure that information to be able to use in this overall picture. So that's a look at the data and where it comes from. We then take a look at Azure Monitor to be able to track this information, and it comes in two major formats: metrics and logs. Metrics are numerical values that are moments in time and are emitted in near real time. The temperature is 85 degrees. It's 85. Oh, it's 87. Oh, it's 85. So metrics by themselves are great, but they don't tell the whole story. Typically, as I said in my temperature example, you might have to consider other things to determine if 85 degrees is normal or not. And this goes back to where we said you should have a baseline of what the expected values should be, and am I above or below those values? Logs, on the other hand, are volumes of information and are triggered at moments in time. So as opposed to near real-time metrics, moments in time will trigger a specific activity log. So somebody has to write a condition going, if this happens, I want to collect all this information and I want to notify it and store it. So somebody has to create the log event, identify the information that needs to be gathered to help identify what might have triggered the log and use to diagnose what the problems are. So there's two different types of information that we have available to us, metrics and logs, that come from a variety of sources that you can pull together from all of Azure or these other sources you're working with. Traces will show the request paths that activities are going through as opposed to just this happened at this moment in time. So we get this volume of information from a variety of sources that we then have to filter out to identify what to do with it. And we break it up into these 4 responses: insights, visualization, analyze, and response. Insights are ways for us to get some insights to how something is performing. Is it above, below? Can we predict a pattern? We get some insights that, do I maybe need to scale something I'm working with? Visualization has been a common piece. I walk into data centers now and I think I'm walking into a sports bar, because in many cases they'll have these big monitors up with all sorts of graphs and data about the performance of all the services that they're working with. Now that's an advanced form of this, but we've got a whole series of dashboards, Power BI. There's a product called Grafana that actually produces reports. You have web pages that push this stuff out. People have PDFs and emails that report back on information. So there's a whole bunch of different ways to create the consumption of that information for the specific people to be able to make decisions around. To help with the analyze features, we have log analytics and tools for us to gather that information and run tools and examples against to be able to extract the information, to analyze it, to see if things are trending in one way or another. But we have a whole different set of analytic tools that we can provide. We won't do a lot of it in this class, but we'll show you some ways to extract that information. And finally, the ability to respond. We'll be doing this in the form of an alert, which is very similar to an action that you can automate, which is what we did. Remember, auto-scaling for both the app service plans and the virtual machine scale sets. It said, if this metric, this CPU utilization, hits a threshold of this over a period of time, so it's doing some analysis, so it's just a metric collected over a period of time, 10 minutes in 1 minute intervals, I then need to do something. I need to expand and add new VMs or contract. So that is a type of response. And we can orchestrate as simple as an email being sent to somebody or as complex as you can think of. We've created complex solutions that will be able to analyze a potential failed part, identify what the part is, be able to create a service ticket through our ticketing system, contact the third-party vendor based around what the part was, let them know that they've been contacted, what the issue is so that they can order the part, and then interact with their system potentially to identify when they're going to be on site to replace it. So these complex systems, as simple or as complex as you need them to be, now provide for some level of action and response that you can program into the system. So the 2 major forms of the data that I've already expressed are logs and metrics. They are split up in my language into these 2 formats of point in time. Now they're emitted in near real time. At the time that the log event is triggered, it monitors at that moment in time and captures all that information. But it is a way to look back to a point in time, maybe weeks afterwards, going, oh, what happened on that day? You can go back to that point in time and look at a volume of information that took place. Where metrics are in real time, you're getting smaller amounts of data emitted in near real time, and it could be quite confusing to get that volume of information. So I need to say, oh, if this, and this happen, I need to be able to perform something or be identified by it. But just hitting that number for a moment in time might not be the issue. And that's why we took a look at the scale sets. We just don't say, hey, if you go over 85%, immediately build 2 VMs. No, we're going to say you got to be over 85% over an average of 10 minutes before we then do a response, because a momentary blip may not need the response. And so you have to think of what happened. Is that a persistent thing over a period of time, or was it just an anomaly that caused it? So that's how we break them up in the way that you want to look at analyzing the information they're coming from. There's a set of logs, the type of log information, that fall into 2 categories. Now we take a look at activity logs from the Azure infrastructure. When did a virtual machine start? When did someone rename the virtual machine? When did it stop? Those are activity logs that talk about the service in Azure itself. But then we get to the virtual machine, we start getting into more information like the diagnostic logs we talked about, the application logs through the application insights that you're dealing with. Now, when you take a look at the Azure stuff, we've got the Azure logs themselves that are going to start to get into the performance of the service, as opposed to someone changed it, someone stopped it, someone started it. What actually happened inside of the environment itself? And you'll see these different logs when we go into the demonstration to see them. The logs are emitted in a standard format and come out in what's called KQ, or the Kusto query language. We store by default all log information for 90 days. We will make that information for free available to you for 90 days. You can go in the graphical interface. We've got these filters, so you don't have to understand KQL. You can, through drop-down boxes, say for the last 6 months, I want to see these kind of logs. Or if you're a KQL person, you could actually use and go to the logs themselves and query the information using KQL. 90 days for free, that's great. The average time between breach and exploit, so I'm going to go to a worst case scenario, is currently estimated to be 200 days. So the time that a system was breached to the time that that breach caused an exploit is more than 110 days different than you're going to have in your logs. So you can go back for free 90 days and take a look at, yeah, we were breached back then, but at what point do I have to go to be able to get a clean backup? This relates to another topic that we said, that you have to have backups to a known good point in time. So how do I know when the known good point in time was? It was hopefully before breach. So it's on you to be able to store this information for longer than the default period of time. This is where a log analytics workbook and workspace come into place. It's a storage location, kind of like a lot of other storage we saw: storage for backups, storage for blob storage, storage for file shares. You're going to create a storage location for the log analytics information to collect this information in a common repository. You can then store it for as long as you want. Now, log analytics is relatively cheap to store that information, so keeping it for long periods of time, and it's still good up to you to determine what that is. You don't want to just throw it away, and you don't want to keep things forever. That's kind of the 2 things that people, I'll just keep it forever. Well, you're going to have so much information, trying to filter it out could cause troubles from, sorting out recent events from long-term events, as well as performance and potential cost over time. So this becomes an exercise in judgment of how long you need to keep that information. So before I close out the module, I just want to give you a quick demonstration of some of the things that I'm talking about. So when we take a look at an Azure resource, and it doesn't matter which one, you'll see some common features in the blade structure. Down the left-hand side, we've got Azure Monitor here, and we've also got an activity log. We talked about the different types of activity logs we have, so I'm going to come into the activity log for this virtual machine. Here is my ability to filter and change some of these. I don't want it for just standalone. What was the resource group that I'm working with? I could add my own filter. But what I'm going to do is, I don't want it for the last 6 hours. I want to change it for a custom value. Now I'm going to go back more than 90 days. Okay? So there's that indication we can only go back to 90 days. But you can take a look at the kind of things that it's showing. Created an update restore point. Checks the resource name availability action. So these are overall activities that are happening to the virtual machine. It's not what the virtual machine is doing, it's what is happening on the object itself. Remember, I went in and checked up the backup features of the service. So that is an activity on the resource, not an activity of the resource. Coming down under the monitoring tab, this is where you start to get into information about what's happening in the resource itself. We got log information, we got metrics, we've got alerts that you can work with, there's diagnostic settings and the workbook. So all those topics I was talking about are now available to filter out information for the log analytics information if you're collecting it, as well as looking at the metrics and log information of that resource. I want to do just a brief example of logs and metrics, and I'm going to come to my local computer to do that. What I want to show you in this example is the difference between logs and metrics and where you could potentially run into some issues. Now, what I'm clicking on doesn't really matter. I just want to give you an example. So on my local computer, similar to what might be running in a virtual machine in Azure, you have Event Viewer, which has a whole series of logs. Now, inside of the Windows logs, I've got an application, I've got security and setup. Clicking on the setup log, this will go back for as long as this log is being maintained. It'll come up with a number of events that were triggered. So I've got an informational log entry that happened at a point in time. So it gives me all sorts of details about this event, what time it took place, and a collection of values that were identified. Whoever came up with log number event number 1, and you'll see other events, event 5000, 5001. So somebody had to say, event number 1, what is it? If this thing happens, collect this information. And so you can see that I've got event number 13, task ID, what the date and time was it logged. So it's collecting a group of information from a point in time. And I've got different logs that I can pull together into a common repository if I needed to. Now I'm going to get down into performance, and these are the metrics that I was talking about. Now, metrics has counters, and there are thousands of counters. And I just want to show you one example that potentially could cause some problems, because this information is so detailed, if you don't know what you're looking for, you could miss the information you're working with. And what often people do is say, give me everything from everywhere, and there's so much of it that it gets confusing. Now, I'm going to take a look at a very specific piece of disks. I want to know how much disk space is available. And so I'm going to come and take a look at physical disk. So under physical disks, there's all these values of disk read time, disk write time, disk idle time. So these are discrete metric counters. Well, that's great. I think I know what I'm talking about. I think disk time is probably the total of disk write time, disk time, and read time, and idle time. Might be, I don't know. They're defined. You can go find that out. So people look at this and go, I don't know what I need. So they say, just give me everything. Add everything. For all the drives that you have, give me everything. Now, if you take a look at physical disks, the physical disk might be 1 terabyte. But let's say you broke it up into 2 logical disks, a C drive and a D drive. So it's 1 terabyte, and it says it's 50% full. Well, that means I got 500 gigabytes. That's great. It's a lot of room. But if it's broken up into a C drive at 500 gig and a D drive at 500 gig, and the C drive is 100% full, it's going to crash. So I've got to look at another counter, and you have to know that it's out there, that there's a logical disk. And so you'll see the exact same counters, but now for the logical disks. And what people do is give me all the counters for everything, everywhere, on every object, and they end up with this tangled mess of values that are emitted in near real time. In this case, it's once a second emitting this information for me to take a look at. So be careful when you look at metrics and logs. Make sure that you're getting the information you need. Identify is it the correct information, validate it, and then set your baselines, and then measure against those baselines for delta differences. Okay, let's go back to the presentation. So we've seen at the baseline of monitoring the concepts of metrics and logs as a way to get information about stuff and everything inside of Azure, as well as other environments that you may want to collect that information about, is available to you to bring together into a central location. Now, collecting them in their individual areas is great. You might be able to diagnose one area, but how does it compare against others? And yes, you could then run different reports from 2 different machines, but collecting it into a single location gives you visibility that you couldn't get by having that independently stored in its original locations. Azure Monitor is a tool to pull all this information together under a single pane of glass, gives you the level of insights that you're going to need to truly monitor how well your organization is performing and how to respond to continue to deliver excellent business results. Thanks for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.